and welcome to another episode of FooBar. In today's episode, we are going to talk about auto-scaling groups and building resiliency in your applications. If you want to know more about serverless, cloud computing, or software engineer practices in general, subscribe to my channel in the red button below. I post videos on Tuesdays and on Thursdays, so let's get started! This is another episode in my series Get Certified with Me, and today we have Cobus again. He will be talking to us about auto-scaling groups, building resiliency in our applications, and all these type of things that are very, very interesting. And we will see some explorations that he's doing with spot instances and on-demand instances and how to get the price right. So it's very, very interesting chat I have with him. So let's go to it. Hello and welcome to another episode with Cobus. This is my new title, I think, for the series. This is like the fourth episode that I'm doing with him. We talk about virtualization, RDS, security of virtual machines, S3, and now we are going to talk about auto-scaling groups. So Cobus is covering all the topics I don't know much about.
All the nonsense. Awesome, thank you.
So, what are we doing today?
Okay, today we're going to be talking about a specific feature of auto-scaling groups. So, just quickly, an overview of an auto-scaling group. It's a mechanism where you define, I want a certain number of servers up and running. So you can say, for example, I want 5, so my desired count is 5 servers up, and my minimum can be 1, and my maximum can be 10. And then what you can do is you've got methods to actually scale up and down using this auto-scaling group, depending on what you want to do. So you can, for example, set a schedule to scale up every morning just before 8 a.m. if you know people are going to be hitting your service then. You can have a schedule then that says at 10 past 5, I scale down again. So it's an easy way to just increase and decrease the number of servers you have running. And also, it's a nice way to actually keep a certain number of them running. Because what auto-scaling does is if, for example, I've got 5 servers running, and one of them, for whatever reason, shuts down. So I can literally go onto the instance and say, shut down now. And autoscaling will then notice, oh, the instance went down, and spin up a replacement for it. So it's a great way to keep your service up and running as well. So to keep them healthy, because you don't have to
manually check the health of the service somehow, or it just checks if it's up or down?
So you've got two options there. The first one is to configure the autoscaling group on the EC2 instance health. So this is literally just, is the VM up and running and healthy according to our stats? And that's the only metric. Whether or not your app on there is running is an entirely different discussion. Then what you can do is the second mode is by asking the load balancer whether or not the instance is healthy. So what the load balancer does is it, via the target group, has got a health check to say where it pings it in whatever interval you have configured and says, is the service up or not? As soon as it's flagged as not up, what'll happen is that autoscaling lets, the load balancer lets autoscaling know. Autoscaling then says, well, that instance isn't up and happy because the app isn't running. Let me tear it down and spin up a new one.
Good. So then we can do that is a little bit smarter.
So I think maybe, well.
Yeah. And autoscaling is like free. It's just you're paying for the EC2 instances that are running under it.
There's no cost associated with the actual running of the service itself in the background. It literally, whatever instance you're spinning up, that's what you pay for.
Exactly.
And that is a very nice intro into what we're going to be talking today, because we are going to be blending spot instances as well as on-demand instances.
Ooh, good.
Yes. So let's quickly cover what is a spot versus on-demand. So what I'm going to show you quickly is when we go to the console, let me just share my screen. So what you can see in front of you is the standard AWS EC2 section of the console. And when you go to instances over here and you click the launch button like we did in one of the previous videos over here, this is where you will launch it. Typically, unless you choose Spot, it'll launch as what's called an on-demand. So on demand, I need a server now, and it'll keep running until I decide to shut it down.
That's what we did.
Yes. So unless there's some kind of event where something happens to the underlying hardware where we need to restart the virtual machine, that VM will always stay running until you decide to stop it. Now, the difference is that with all our different data centers and availability zones that we have, we've got a large amount of spare capacity, because it wouldn't be a nice day if you couldn't spin up an extra VM. So we do a lot of capacity planning and know exactly how large to increase the number of servers, etc. So we always have the capacity available. But as you can imagine, it's sitting over there, and there will always be a chunk that isn't being used because it'll be for future use. So what the teams came up with is saying we've got this concept of a spot instance, where the spot portion comes from spot pricing in terms of what it costs you to run it, but we'll get to that just now. And what it means is that you can actually make use of that extra capacity, with the caveat that if we need that capacity, we'll give you a 2-minute warning and saying we want to take that image or that instance back and use it for something else. And then you need to, in those 2 minutes, decide how you want to shut down your workload, save your workload, whatever. And especially if you're thinking in the container world, because we're already used to containers coming and going the whole time, our apps are typically built to handle this. So it's a very, very good match for container workloads. And the benefit is you can get up to 90% discount. So
that's crazy.
That is, yeah, that's a massive amount of savings. And you can actually see what those prices are inside the EC2 dashboard if you go to spot requests over here. And if we click on the pricing history over here. So what you can do is you can, for example, take a look at the last 3 months. And you can see over here, just this is a C3 large, which is an older instance type, because we're on the C5 large already. That these are the old ones. So if I look at something, for example, let's take that C5 example, look at the C5 large. We can see over here that the price didn't really fluctuate over the last 3 months, which is a good indication that there was always constant availability of these instances.
So it will be very safe to put your load there. Nobody will terminate it, basically, based on statistics.
Yes, and also on statistics, let's put a number to that. Over the last 3 months, we've only terminated 5% of all spot instances across all our regions.
Wow.
So that's not a lot. And that is if you happen to get unlucky with your specific instance family and specific instance type was needed. And what I'm going to show you is with the autoscaling groups, how you can actually spread across multiple different families without too much config to take care of that.
Put all your eggs in different baskets. So if some virtual machine like type gets very popular, then you're safe.
So what will happen there is that because the autoscaling group, you tell it what your desired count is. You'll say, well, I want 5 copies of my server running. I'm happy with C5 larges, M5 larges, R5 larges. Exactly. And then what will happen is, let's say the R5 larges become unavailable because of demand. It'll spin up the other ones, M5s or R5s. So yeah, so we'll take care for that. And then just quickly, where the spot name comes in is the spot pricing, as I mentioned. And what you can see over here is the black line at the top is the on-demand pricing, which is 9.6 cents per hour for that instance. And what you can also see there is that these specific ones are a third of the price at the moment. So they're 3.4 cents, or roughly a third. So this is, you can see already that you're saving 66%-ish on the instance cost by running spot at the moment.
And it depends on the type. Some of them have a bit bigger savings and others have less savings. So
yeah. And if you go to, normally a nice one to look at is the P3 instances. So these are they're very big instances with GPUs attached to them for machine learning. So they are big and they're expensive. So if I look, for example, at the P3 16X large.
That's huge.
Yeah. It actually had no fluctuations. So let me look at let's say the P2 one. Maybe there was some. Nope.
No.
This is actually very amusing because we'll have to find something that had fluctuations over here. Second, that one wasn't available. This is okay. Let's look at the G family. That sometimes has some fluctuations.
No. That's a good proof that you can use spot instances without really worrying too much.
This is now quite amusing. Okay, I'm going to now go for my other one, the M5. Maybe they had fluctuations.
Yeah.
Finally. So M5 are general purpose ones, so they tend to people because they've got a 1:8 ratio between memory and CPU. So if for every CPU there's 8 gigs of RAM. So they're very nice. Middle of the road if you're not sure what workload characteristics you have. So over here you can see that they did fluctuate a little bit, and you can see the fluctuation is per availability zone. The price is different. So over here you can see it fluctuates. So spot price, how it works is, or previously worked, is that when you launch a spot instance, you would say, I am prepared to pay $1 an hour for this instance. And the current spot price, if we look at this, is, for example, 16.2 cents for the 1B availability zone. What would happen then is that once that price is below that $1 that I specified, my instance will keep running and won't be terminated, because anyone else who's bidding lower than me or lower than that price would then get into the pool of, we need to terminate you. Here's your warning. We're going to take
like an auction or something like that.
It's like an auction, except you say, what am I prepared to pay, not what am I currently paying. So you would always pay the spot price. So this 16-cent price is what you were paying, even though you said, I'm prepared to pay $5. But what you could do is, by bidding very high, you know that there's a very small likelihood of your instance actually being terminated. So as an example here is, before I joined AWS, I used to run my Jenkins primary nodes as spot instances, because the longest I ran one was, I think, 9 months, and the only reason it terminated was because I wanted to change it to a different instance type. So you can get, and I said, is pay $5, and then I knew it wouldn't be terminated.
Can you put like the value of the, I don't know, hourly of the normal on-demand price, or even higher, so then nobody will terminate it?
Well, what you can do is you can go very high. Now, in certain scenarios, if we run out of capacity for that specific one, no matter how high you put it, obviously we'll tell you, hey, listen, we need this because we are the ones left of it. But you can put on demand, so you know that you won't ever pay more than that on demand. And the interesting thing that we'll see now when we set up the autoscaling group is we don't specify a spot price. And you can if you wanted to, but that complicates it. So what we did with the interface is, by default, it will use the on demand as the maximum that you'll pay. So when you add spot instances to your autoscaling group, you know that you will never pay more than the on-demand price, which is great, because then you know that, listen,
it's cheaper or the normal price.
Yeah, so it's a good way. So now that we know what the spot prices and what spot instances are, let us go look at a autoscaling group and how to set it up. So for that, you would head down here into autoscaling groups, at the bottom in the EC2 console, and you would just click the button that says create autoscaling group. Now we're going to give it a name. So let's say FooBar codes for today. And then for this, I need to specify a launch template. Now, luckily, I have got one over here that I'm going to use. And you can see that it's got a bunch of configurations with regard to the security group, the AMI ID to use, because we need to know what AMI ID. And just quickly, with these launch templates, what you'll see over here is a version. So that if I want to make a change, for example, to the let's say the user data I want to use when the instance spins up, or if I want to use a different AMI to spin up the instance, that will create a new version. The reason for this is that you can't edit a template, because imagine you've got 5 servers running, and now you edit and you launch 5 different ones. You've got no idea what's running anymore. So you need to
what is inside in a template? It's like the AMI, and what else?
AMI, security groups, what SSH key to use, user data. There's quite a lot of configuration available in there that you can do, but you can also, a lot of those configs you can override inside the autoscaling group. So it's a template saying, here's what I should be running, but you can override it as well.
Good.
Yeah. So what we're going to do is we're going to say next. And now this is where the fun comes in. And what I'm going to do quickly before we change these is I want to jump to my slides to show you or to explain what we're going to be doing, because this can get quite complex. So before we get started with exactly all of this, I want to explain 2 concepts. The first one is what we are optimizing for, which will be the either capacity or cost. And the second one is, how do we include different spot pools inside our autoscaling group that we can pick from. So just quickly, like I showed you with that spot pricing, you saw that the spot pricing is different per availability zone. So when we think about the pricing, the first thing is we talk about the family that we're dealing with. And in this case, it's the C4 family type. Then what we're dealing with is the size of the instance. So is it a large, extra large, or 2XL? Then we're talking about the different availability zone. And then ultimately what you have is each one of these, in terms of, if you look at these specific pools in every region, for every family type, for every family size, as well as availability zone, is a unique price that we are dealing with. So that's what you see in those yellow blocks over there. The specific price of those different parameters gives you what is that spot pool pricing going to be. So that's a separate spot. And then also it's different for all the different instance family types that we're dealing with. So just remember, obviously the spot price for a C4 2XL in availability zone 1A is different for a M4 or M5 with all those configuration values.
Yeah.
So lots of configs. Good news is, don't worry, this is very simple when we get to the end part where we actually configure it. So but you need to understand what this works. So now that we know how that pricing works, is the first question we say is, okay, cool, what do we want to optimize for? And the good news is you've got a choice between capacity optimization or price optimization. Now, remember when I said that when there's not enough capacity left, we are going to start terminating instances and telling you, hey, listen, we need that one back. Here's your 2-minute warning. Please shut down your app or service that you're running. What you can do is you can select the capacity optimized allocation strategy. And what this does is that if you look at these 3 different availability zones in front of you, and you see the 3 different instance types, the R5 large, M4 large, and the M5 large, you'll see there's a bar on the right to the name, and the different sizes that indicated by that bar. The size indicates the amount of capacity available. So when you say optimize for capacity, in this case in US East 1A, it'll go for the R5 large because there's the most capacity available. Because the more capacity, the less likely you are of being terminated.
Exactly.
Yeah. So what you can do is you can specify that I want to make use of R5 large, M4 large, and M5 large, but capacity optimized, so it'll in each one A go for R5 large, the middle one will go for M4 large, and the last one will go for M5 large. Now just remember what I'm doing is I'm specifying 3 different instance families, so it'll go for those ones first, but if it can't find capacity for those, it'll go for the one with the second most capacity. So in the first one, it'll go for M5 large. After that, if it can't fill everything up with R5 larges. So this is just if you don't want to have that constant, and remember constant being 5% across all regions worldwide interruptions of Spot instances. I always just want to put it into context for people because it doesn't happen often.
No.
You can make that even less by using multiple ones and going for capacity optimized. So this is how you can do for capacity optimized. Then what you can do is you can do also go for lowest price. So if I say that I want to use R5, M4, and M5 larges, go pick the one that has got the lowest price, spot price at that point. So obviously that grid that I showed you before, it'll go and pick whichever one's got the cheapest in there. And the thing to take into account there is that you can also apply a weight to this. Now, to do that, let me quickly jump to this slide to show you. Which is, if you think about your auto-scaling group, you're going to be filling it with different instance sizes. So in this case, we've got M4 extra large, M4 XX large, M4 4X large. Now, if you think about the scaling, how that works is a extra large is half the size of a 2XL and is a quarter of the size of a 4XL. And if you're launching, let's say, a container on this, and you know that with 2 CPUs and 4 gigs of RAM, I can process, let's say, 50 requests a minute. If I've got something that's got double the size, I can deploy 2 of these containers, so I can deploy double that. So what you do is you assign a weighting to it. So what you say is that you can see here the M4 2XL has got a weight of 2, and the M4 extra large has got a weight of 1, which means that when I go to my auto-scaling group and I say, across all of these different instance families and instance sizes, with this weighting, go spin up 5 instances for me, please. If it only looks at the M4 family, and it can do that by spinning up 5 M4 extra larges, or it can do that by spinning up 2 of the M4 2XLs and 1 extra large, or one of the very big ones and one of the small ones there. So it'll use this weighting to figure out how many instances to spin up, and also then knows how much capacity you've got available in the group. And where it comes in with the pricing, interesting, and once again, to make this simple for you as the end user, if you take that grid that we had, then you apply the weighting to the on-demand pricing using the weights of the sizes. You get the weighted on-demand price, which is the same because they scale linearly in terms of cost. But if, for example, look at the spot pricing pools for the different sizes, you can see that there are quite a lot of different. So all of this is abstracted away for you and taken care of by you just saying, I want to optimize for cost or capacity. And then it'll take all of this into account when it starts spinning up the different instances for your auto-scaling group.
Okay, so it's super smart.
Yeah. There's quite a lot going on in the background. So let me jump back to the console quickly to show you what that looks like when you create all of this. So what we can do over here is that we're going to say what is the on-demand instances that we want. So what we do here is we say what is the base. So if you think about my auto-scaling group, I'm going to be using Spot and on-demand. I want to define what's the minimum on-demand that I want. So you can say I want always to have at least 5 on-demand instances, which means that you know that if the Spot instances go away, you'll always have at least 5 of them running, and then it'll try and fill everything else with the on-demand Spot ratio that you specify. And then you can specify for the remainder what's the percentage split between the two. So you can go 70 on-demand, you can go 100 on-demand, and what you'll see then is, sorry, just validation there. So if I go Just click on the button and wait for it to go up to 100%. You can see that it updates the on-demand. So now what will happen is there will always be 5 instances on demand, and whatever the rest is that I want, it'll go for spots.
Then and this is inside all the availability zones that you want to have your auto-scaling.
Yes, remember, auto-scaling group is inside a specific region, so depending on the size associated with it, that'll be how it picks which availability zones it uses.
So you pick 5, you want 5 on demand, and they will be distributed into multiple availability zones.
Yes, so it'll do that for you. And then what we can do over here is it says that we can pick the either capacity optimized or lowest price optimized over here. And then for the lowest price, what you can do is, because we're going to specify what instance types we want to use over here, you can also, for the lowest price, say which of these pools do you want to use. So let's say over here I go m5.large. Just want to add a couple here. Let's add another one. Oh, okay, so it's got a couple down here already. So you can see this is my pool of instances. I've got m5d large, m5 large, and m5a large. So over here I can say when I go for the spot instances, which of these ones should I be using? So I can say, well, let me use the first 4. So it'll use this one, this one, this one, and this one when it starts looking for those lowest spot prices. So you can actually have different families for the base on demand as for in terms of the spot ones as well. And you can do handle that in terms of configurability, what you want.
Okay.
Good. So what we're going to do is we're going to make it simple. We're going to go for lowest price. We're going to specify 2 only. And so now what I'm going to do is I'm going to reduce this down to just the few ones we want. So let's go for m5.large. We select it. We give it a weight of 1. And then over here, what we do is for the second one, let us go for c5.large. And we're going to give it a weight of 1. And for this one, we're going to go for r5.large. So similar to the slides that I showed you. And then I'm going to remove all the extra ones down here so we can see what the pool looks like. So these are the 3 we've got. So when we use Spot, we're only going to be able to use the M5 large and the C5 large because of that 2.
Great. And the last one will be used for the on-demand or?
Well, it'll use these 3 in priority. So for the on-demand, it'll start off trying to use M5 larges. If it can't find any, it'll start using C5 larges. If it can't find any, it'll start using R5 larges.
Okay.
So that's how the tiering of that work. And similar with the spot, it'll start off with trying to find M5 large spots, then C5 large spots.
Good.
Okay. And then this is that question you had about which availability zones it'll use. It depends on what subnets you select because the autoscaling groups span subnets. So if I pick A, B, and C over here, it'll use all 3 availability zones for that. And then I can go to the next button. Now we click on next and we can actually create our autoscaling group. And the reason over here is, so this is that load balancing question we spoke about earlier in terms of figuring out what the health checks should be. And you can see over here that it defaults to EC2 because there is no load balancer. So if I had a load balancer, I could check this box and then go for the ELB health check over here. And in terms of the additional settings over here, this is for CloudWatch metrics, which we aren't going to be covering today. But you can get more granular detail metrics with CloudWatch as well. We're going to go to the next button, and this is now where you specify what size do you want available. So you can say desired capacity, for example, is 5, minimum is 1, and maximum is 10. And now let me just show you there. What you can see is that your maximum and minimum need to be below and above the desired count, because obviously it won't make sense. You can't give it invalid configuration. Then also in terms of the scaling policies.
So now basically with that setup that we had with the 5 on-demands, it will be basically those desired will be the 5 on-demands that we have. And then the rest 5 will be covered mostly, with only spot instances.
Yes, when we do scale up and down. So that's the thing that I want to show you now with the scheduled scaling that's super useful to know about. So in this case, we're not going to look at this target tracking scaling policy because you can also configure your auto-scaling group to scale based on CPU, memory, network, disk IOPS. You can even set custom metrics in CloudWatch. Anything that you can measure with CloudWatch, you can set an alarm for to decide to scale up or down. So it's entirely up to you how you want to do that.
Nice.
But for us, we're just going to do the easy scaling with time-based one. And we're going to go next, and to the final one, and we're not going to give it any tags. What you can do over here, it's a useful one, is to always add a name tag, and we can call it FooBar again. And the reason is that when the instance comes up, this means that it'll have a name at least. Otherwise, it'll just be blank.
Yeah. That's something I learned with you, how to name my instances.
We should actually wait. Let's go back. We can do that with that rockets.
Oh,
It's a history. We have to use the rockets. Copy. Let's quickly edit the tags over here. Put a space in there, make it look pretty. There we go. Cool. Now we know that it'll launch for that and create autoscaling group. And now what you can see, it's now creating. And if I go into the autoscaling group, you can see all the configuration that we specified over here. And if I go to activity, this is where the fun happens. Now you can see over here that it's automatically trying to launch 5 new instances because that's the desired count that we specified over there.
Yeah.
So now if I go up here into instances,
we need to do some filtering.
A lot of rockets.
Yeah, 5 at least. There is 6, but that one is from the previous time we set up.
Yes. So what you can see over here is that we now have 5 that are currently busy initializing and spinning up. So that's how it handled it. And because it was able to get 5 M5 lodges, it used that in terms of the instance types. But obviously, if that wasn't available, it would have used different types.
Can it happen that on demand there is no capacity?
Yes, because on demand, when you launch, once it's launched, there's the guarantee that we'll keep it running unless the hardware underneath it fails.
Okay.
But on demand, we have in theory, fixed capacity size. Because remember, we've only got so many servers in the racks on the locations and of the different types. So there is a scenario where you could say, I want to launch an M5 large and there is no capacity available. For the common types like M5, C5, that generally won't happen. I mean, I personally haven't seen it happen, and I've been building on AWS now for 9.5 years. But it can happen if
maybe if you want, like, I don't know, something very particular and you want the whole metal thing, maybe.
Yeah, I mean, if you go for the specific, like the P3s or the P or the those instances, they're definitely only a certain amount of them. Or if you really want expensive X1s, those are the 24 terabyte RAM instances.
Wow.
Yeah, they're big. But so what we have over here is now we've got these spinning up, and it's not going to be much fun just watching them spin up because they won't do anything. So let me go show you about those, the scaling, because that's fun.
That's our auto-scaling group.
Yes. So now what we can see over here is a tab for automatic scaling. And what we can see is that there is no scheduled action. So what I can say here is create a scheduled action. And let's call it scale up. I don't know if you can use spaces, but we'll find out. For morning coffee. We can take the desired capacity up to, let's say, 10, because we know we need that. And we want to take the max to, or the minimum we leave at 5. But you can change the maximum to, let's say, 15 here, because what happens is if you're going to be pre-scaling, you might still want to do normal dynamic scaling on top of that, depending on what your workload is. You just want to pre-boom it. So what this will do is it'll actually change that minimum maximum at that point in time to the values you specify here.
So this could be the use case, for example, on the weekends, if you're an e-commerce store, when people buy, then you have this kind of more capacity that you know in advance.
Yeah, the two scenarios here. That's the one. So, for example, let's say you need to scale on Saturdays.
Yeah.
Let's actually do that quickly. We can say this is every week. We are going to scale on. Let's pick the coming Saturday, which is the 25th, and we will be scaling at let's say 7 a.m. because we know people.
That's server side, the time, Ireland.
Yeah. Yeah. So what will happen here is you can see here. This is the start time. Now I can set the end time. And let's say that is on Saturday evening at, let's say people stop shopping at 9 o'clock at night. So we create that. So this will be the scaling up event. And you can see here, this is cron like syntax in terms of, you can see that it happens every 7th day of the week, because it starts with Sunday being 0th day of the week. 7 a.m. and Saturday it starts with. You can see here what the values are going to be. And now what we say is we create another scheduled action, which is scaling down. Scale down. And we say we're going to go back to 5, 1, and 10. This also recurs every week. And we say the start time is, where is that, Saturday? And this one will run at 9.
And the other one finish, basically.
Yeah, so that's when you scale it down.
Good.
Oh, sorry, that's the mistake I made. Sorry, what I did wrong here is that in this, the end time there is not the end time of when it scales down. It is actually the end time of when to end this recurrence. So yeah, so sorry about that. What this needs to be is, so I can set this to happen, for example, until, let's do it December the 26th on Boxing Day. So that's the last time we'll actually do this scaling up. So then you can see, so the difference here is for the second one, the scaling down will happen the whole time. And then when this time hits, so actually what we can do, just to make this a little bit more fun, is let's create one quickly. Scale up now. We're going to go to 10, minimum 5, maximum 15. This is going to be once. We're going to select today, and we are going to, this is UTC. So we are looking for 12, 12, and it's almost 10 past. So we will pause the video and show you when this starts scaling up.
Woohoo.
Just quickly show you here, we can see that all 5 instances are up and running.
Good. So they're ready and taking requests from our busy users.
Yes, we have got a big commerce site running. On that note, actually, if you haven't been able to attend one of the AWS game days, I would highly recommend to, especially if you want to learn about things like autoscaling groups. It's this simulated environment where you're taking over the tech side from a company and you need to scale up. You need to use autoscaling groups, add caching, add CDNs, etc. And then they start breaking things in the background. It's all about selling unicorns. So it's a lot of fun to attend. And we have got, according to my watch, 10 seconds left before this will start kicking in. So I'm going to give it until 5 seconds after. And let's take a look. If I refresh over here. Oh, here we go. Executing scheduled scale-up action now.
Oh, nice.
It's in the process. So
now we will start seeing the spot instances coming into.
Yes, because what happened now is you can see here, let me just refresh this page. Sorry, give me a second. So now you can see desired is 10, minimum 5, maximum 15. And if I look at the activity, let's just give it a second. We might have hit the cooldown period now. Let's just look at the timestamps. That's 5. Cooldown activity. So just quickly, if you were wondering about that.
What is that, the cooldown activity?
So with an autoscaling group, when you scale up and down, you can set a time period about how often it can make that scaling adjustment. Because let's say something is wrong with your system, you don't want to scale up every 5 seconds. That's just to say those steps that it takes, how quickly can it take those steps effectively.
So because we launched the instances so few minutes ago, then maybe it doesn't want to scale right now.
Yes, so that's what I'm just quickly checking here with the timestamps. Let's just double check.
Things happen.
Yeah, so things happen. So you can see here it actually scaled up 5 more of them. And if we go to the details tab over here, this is the configuration that we have. No, it doesn't show us the instance types. Let's go to instances over here.
Ooh, now it's very crowded.
Yes, so now we can see here and here we can start seeing, we've got some C5 lodges now. So now we've got different ones.
And how you see if they're spot or on demand? Can you see that?
So when you click on them, let me just quickly bring this up a little bit. You should be able to, there we go, lifecycle spot.
No, nice.
So you can see over here, so the C5 here is, so let me scroll down quickly. So if I go back to one of the other ones that we launched previously, which is, and I can see that it's that one because of the fact that it's already initialized. Over here, I can see lifecycle is normal. It's not spot.
You said that you will get a message 2 minutes to turn off your instance. So what you will get inside your instance, you will get like something, or how it works?
So that works by, there's a SNS notification that gets sent that you can then decide to process. But also with the autoscaling group, if the spot instance is inside an autoscaling group, there's a mechanism there that it sends a message to the actual running code inside of that instance that, hey, listen, we're going to be doing termination. And then your code inside that instance needs to decide if it wants to listen for that and act on that message or not.
So you should have, if you're using spot instances, something that can handle that notification, basically. You need to be prepared for that.
Well, either that, or if you think about your workload when you write your app, if you start looking at your exit codes that you send to it, so the sig term codes that on a low level the kernel sends to each individual process, the different termination signals that get sent, and it needs to. You can build your app to, for example, there's quit, where it will then. If you send it the first time, your app can then actually react to it and shut down. If you send it the second time, that's when you do, for example, Control-C and you hit it a second time. Or you can do, if you send that -9 kill command on the console, that's a force kill. That's a different signal that the app can decide what to do with that. So your apps can react to those different. It's very low level in terms of how the kernel handles specific processes. But that's how it does it.
Yeah, but you need to prepare. That's kind of the thing. It's not that, well, you can leave it die and it will terminate, but then whatever you are doing, it will get stuck in the middle. So either you build something that is very resilient or then you prepare for it.
Hopefully. Well, the thing is, you should be building your app and asking these questions up front. In any case, what happens if my instance shuts down right now? Did I pull a message from a queue, so it'll go back onto the queue saying not processed and something else picks it up? Or is it a case of I need to quickly snapshot my workload where I am now and some other process will pick it up? That's entirely dependent on how you build your app.
Yeah, but be aware of this. It's not like, I think that's something maybe a little bit new for maybe app developers if they're used to building their applications on instances that never get shut down. But if you are using these, and they might get shut down after only that 5%, but be prepared.
Well, the thing is, if you think about it, you might think you're building an app for an instance that will never shut down, like on-premise instance, but at some point someone's going to break something or pull a power plug, or it's going to reboot.
And I think it's always good to build as resilient applications as you can. And I think that's something you learn with the serverless ecosystem, but that's something for another video.
Cool. Okay, so that's it with the autoscaling groups that I wanted to show you today.
Awesome. So now we know something new, and I think it was really nice to learn so much about Spot instances because they're very, very useful.
Cool. Awesome.
So thank you, Cobus, and I'm pretty sure we will see you again in a couple of weeks.
No worries, there's a lot more to play with here.
I don't know how many services AWS has, but I don't know them all. So.
More than 213 last time I checked.
Oh man, so we have plenty of time.
Oh yeah, no, we've got lots to talk about still.
Definitely. So thank you very much and have a great day.
Awesome. Bye.
Bye. This was the video for today. I hope you like it. If you did, give a big thumbs up and let me know in the comment box below what kind of topics are you stuck in your certification and I should be doing a video about them. We can ask Cobus or we can ask someone else. Let me know. And don't forget to give a big thumbs up. Thumbs up really help me out to grow my YouTube channel. And that's it. I see you in the next episode of FooBar. Ciao, ciao!